Okay, let's get started with Koala Behavior Trees. So I have a completely clean project and I'm gonna import my custom package that includes my library. And it will take a few seconds to decompress and I will import everything. Now it will compile the scripts and import my structure nodes as well as the examples it includes. Almost there. There we go. Now I'm ready to start building my artificial intelligence, so I will create an empty which I'm gonna call NPC for non-player character, and I will add a cube to it so I can see it, and I will reset its transform. Now I will add a koala brain and it's almost ready to be used. So to prove this, I will choose a structure example, and you can see that right now my inspector reacts to what I have selected. So I'm gonna lock this inspector in the NPC so I can always have it there, and add a new tab with a new inspector, which I'm gonna put down here. Okay, so now I will put my random example tree. And this tree, every time it's ticked, it chooses one of these actions at random. So I can click on an action and see its details in the new inspector. And now I will reset its status and then tick on it. And you can see that it chose to move to this location, but nothing happened. But that's because it's already there. So next tick it will succeed. And if I tick again, now you can see it reacting. That was simple enough, and there was probably no need for a video tutorial about it, but trees actually have a few nuances that I think it's worth discussing. Okay, so the first thing you should be aware of is how ticking works in the editor. I will go into the different ways you can tick a tree in a different video, but for now let me show you the following example which can lead to unexpected behaviors. So let's say I'm working on my tree and I have nothing selected, so my unlocked inspector is not showing anything. Now I tick on the tree, and because it's random, the first time it failed, but now it chose to move to this location. And it's not there yet, but it's not moving. And if I tick on my tree, nothing happens. But when I select the action, now it performs it. And now that I have it selected, I can tick again, and even if it chooses a different action, it does it in the editor. Now, this behavior can lead to unexpected things because each time this event is invoked, a coroutine is started. So if the game object doesn't make it to this location, that coroutine will still run until I reset the status. So the lesson to be learned is that if you're ticking your trees in the editor, you have to have some nodes selected in order for the actions to work properly. Now, the second interesting thing that you have to be aware of is the relationship between the scriptable objects and the game objects. Now, these trees live on the serialized part of Unity, meaning that these trees can be used in many different projects and with many different game objects, so that each time the tree needs to know something about the game object, such as its position, that information the game object it's working on should not be stored in the scriptable object, because this scriptable object can be used for many different things. So what needs to be done is that the behavior, the brain, the koala brain on the game object informs the tree which is the game object that it's referring to. And when I run the game, let me run it. It's taking a bit longer than it should. There we go. You can see that now the tree it's running has changed. The name of the tree is now runtime. The name of the root is now runtime root. And this random node does no longer reference this random node. It's actually a clone of it, and each node is a clone. So each brain will have its runtime copy of the node, so that it will only check against its own variables and stuff. But if I'm in the editor, this tree, it's actually a reference to this tree. So if I made a copy of my NPC, let's just duplicate it, and let me move it somewhere else and give it a material so we can see it. I will give it a green material. There we go. And now this inspector is inspecting the first NPC, and this inspector refers to the second NPC. If I tick in the second NPC right now, the one moving is my first NPC, the white one. Actually, if I inspect my action, I can see that it's the white cube that it's moving. That's because the last time I clicked on reset status, it told the tree, the behavior tree, that this is the game object it should be driving. Now I can do the opposite. I can select my second NPC, reset the status from here, and even if I click tick on the first NPC, it will now move the green cube. So every time you tick on a tree, if you're in the editor, you have to select which game object it should drive. This is also true for newly created trees. So for example, if I create a new tree, let me make a folder, which I'm going to call tutorial. And then inside of it, I create a new tree, going to right click, create Koala Behavior Trees tree. And I call it tree A. Now I'm going to inspect it. And I'm going to create a new root. And I will add to it a condition node. Condition nodes take a method that returns a boolean, and they succeed or fail depending on whether the boolean was true or false. And that method is to be stored inside a scriptable object. So the library has a few standard conditions, which are in this Koala conditions scriptable object, and then I can select the method I want to use. So for example, this method, health issues, checks whether this number is greater or lesser than 30, I think. So if I change this and if I tick it right now, it will give me a null reference exception. That means that the tree doesn't know which game object I'm referring to. So I need to reset the status to tell this tree that this is the game object it should be referencing, and then I can tick it and it returns succeed because this number is greater than the condition I defined in the method. I will go into the condition node with a bit more detail in a future video, but for now what's important is that you need to reset the status to tell the scriptable objects which game object they're driving in the editor. But if you're running the game, that's not necessary because a copy of the scriptable object is created at runtime. I also wanted to mention, which I forgot in the features video, that the Koala Behavior Trees are using an open source library called SoHi, which takes care of building this tree representation on your inspector. And this can be used for many different things, from artificial intelligence, but you can also do dialogue trees or containment information. So maybe it would be interesting for you to check that library, and there will be a link in the description. Okay, so this video has been long enough. I will make a second part on this getting started, in which I will go into the different nodes we can use and some tricks about using trees inside trees. See you soon. Thanks a lot.